Here's another important idea that's going to be used in the development of the theory of integrals. If we have a function f of x represented by this graph here, and we have some number small m, which between x equals a and x equals b is less than every value that we get for f of x, and we can see that that's the case here, m is clearly less than every f of x, then we can conclude that the integral from a to b of f of x dx, which of course is represented by the area under this graph, is greater than m times b minus a. Now what's m times b minus a? Well, isn't that just the area of this little rectangle down here? That from the picture we can see is clearly less than the area under the graph of the function. Again, this rectangle has dimensions. Well, the altitude is m and the width is b minus a, so its area is m times b minus a. Similarly, if big M is always bigger than any value of f of x, then the area under this straight line between a and b is clearly greater than the integral, or the area under the f of x curve between these 2 points. And we say that m times b minus a, which is the area of this rectangle, as you can easily see, is greater than the integral from a to b of f of x dx. So we have the statement of an important theorem, that if between a and b, for any x between a and b, little m is less than f of x, that's for all x's between a and b, and f of x is also less than m for all these values of x, then it follows, and you can see easily why it should follow from the picture, it follows that the integral from a to b of f of x dx is less than m times big M times b minus a and greater than little m times b minus a. And if we want to really prove this rigorously, then we'll break this into, we'll break the integral from a to b into small intervals of width delta x and look at what happens in each of those intervals. For each of those intervals, little m delta x is going to have to be less than the average value of f delta x, since m is less than any value of f. And also, this is going to be less than big M delta x, since of course any value of f is less than big M. And if that's true, it's going to be true if we take the sum over all the delta x's. And if we consider what happens to the Riemann sums, we can very quickly conclude that this inequality has to hold.